Good morning, everyone, and thank you for coming to this talk today. My research area is the Basque country, which is in between Spain and France in the Bay of Biscay. And it is a short area, 120 kilometers more or less from France to here, to Bilbao. And we have 12 estuaries and the coastal area which we monitor since 1995. I'm going to show you this area, which is in between France and Spain. It's an estuary, which is called Bidasoa, to show you the changes in the habitat with loss of habitats and transformation between 1945, which you can see here, and the situation now. And you can see that there are many infrastructures, and the area has changed from the intertidal area to a subtidal area. So this means that there are many transformations in the habitats and the species living there, etc. Also, we have experience in this area, not only in this estuary, but in the whole area, pollution in the 20th century. But after that, we have different monitoring and management measures. We have reverted the situation. So we try to explain this or study this. A few years ago, we published this paper in which we studied the long-term series of monitoring in response to human pressures and the management measures. This is to show you the work we did. Here we have the number of different series, long-term series, for different variables, dissolved oxygen, pH, silicate, etc., and the percentage of the series for which there is significant change, either improvement or worsening. For example, for dissolved oxygen, from the 83 series, near 40% are improving and 20% are worsening. It's the same in other cases. Hence, you can see here the different matrices. The water we have seen, in which there are mostly improvement, but there are several variables like silicate, nitrate, and suspended solids we have worsening, and this is because of the increase of the rainfall. But for many of the variables, there are an improvement. This is particularly noticeable in the sediments, in which most of the variables have improved, especially organic matter, which have reduced a lot of, and the improvement is near 60% of the series have improved. And in the case of biomonitors, which we sample in mussels and oysters, all of the significant trends are improving and none are worsening. In the case of the phytoplankton, there is mostly a worsening, and this is because at the beginning of the series, we have a lot of suspended solids and turbidity, so there is no chlorophyll at all, or very little chlorophyll. After cleaning the waters, the chlorophyll has increased, and this means that there is like a worsening, even if it is not true. In the case of macroinvertebrates, you can see that for most of the variables, the improvement are very spectacular, especially using MAMBI, which is the index we use for assessing the status, in which 45% of the significant trends are worsening, are improving, and very few are worsening. And in the case of fish, all of the significant trends are improving. The current situation regarding the ecological status is most of the areas, either in estuaries and coastal areas, is in good or high status in terms of the Water Framework Directive, but still there is a part of an estuary which is in bad status because they are completing now the water treatment, and another estuary which is in moderate status, but it progressing towards the good status. And in the case of chemical status, we have two estuaries, the Nervión here and the Bidasoa here, which are still in not good status because of several pollutants. And I'm going to show you now the paradigmatic example of the Nervión estuary, which was very polluted in the past. These are photographs from the 60s and the 70s and the 80s, which was a very industrial area with mining, with siderurgy, etc. And the pollution was very evident. But then in the 80s started the water treatment, and this is the increase of the inhabitants served by the water treatment. Now all the population is served, and in 2001 the biological treatment started. And after this, you can see along the estuary different stations. This station is here, this station is here, and this station is here. And you can see the evolution of nutrients and oxygen in waters. There is a decrease in the concentration of the ammonium or phosphate, and an increase in the case of oxygen. And now the nutrients are below the limits. This is the limit, and the oxygen is above the limit, so it's got okay. The same is for the pollutions in the contaminants in waters, in which there is a decrease in the concentration of metals, as you can see here in most of them, and now most of them are in below the limit, so they are in good status. For phytoplankton, again, you can see a decrease in the, so they are below the limits. Now it's in good status. And macroinvertebrates are increasing, for example, from a zoic situation to a good or high situation in the inner part of the estuary. In the middle part, again, is increasing, but in the external part, in this part, they are decreasing, and even now it is in poor or moderate status, and this is because the wastewater treatment plant is here, and there is a discharge here still, and even if it is clean water, or still there are some loads from nutrients. In the case of fish, in the internal part and the middle part, you can see again there is an increase in richness, abundance, and diversity, both for crustaceans and fish, and the whole community of fish. There's an improvement with time. But also we have studied the recovery of ecosystem services for two of them, which is recreational fishing and beach recreation. We have studied the evolution of the environment, but also the socioeconomy, the accessibility to do these activities, but also we have studied the perceptions, the behavior, and the monetary value of these two activities, and from the demand side. And we have seen that there is these uses have covered 100% beach maintenance costs covered, and 20% of water treatment costs are covered with these two activities, with the travel and the use of the area for these activities. So we think that studying all the ecosystem services, probably 100% of the water treatment costs could be covered. As a summary for this, you can see the evolution from the 80s to the nowadays. From the bad situation to the more or less recovered situation. This is the inhabitants covered by the wastewater treatment. And now here you can see the evolution of oxygen saturation from hypoxia or even anoxia to the current situation of a recovery. The sediment pollution from heavy pollution to moderate pollution now. For benthic communities, from a zoic situation in the inner part to the recovery now situation, recovered situation now. In the hard bottom, in the external part, from poor situation to good situation now. The demersal fish from a zoic situation again to a recovered situation in now. Seabirds again follow the fish, and it's recovered now. For the ecosystem services, both bathing and recreational fishing, from low situation to the recovered situation. As conclusions, the long monitoring networks are basic tools to track the impacts of human pressures and the effectiveness of management measures. Even most degraded marine systems are able to recover. However, ecosystems need time to recover, usually decades. Physicochemical properties recover first and quickly, especially in waters. Lower taxonomic levels like plankton or macroinvertebrates recover later. Higher taxonomic levels like fish or seabirds follow recovery depending on the food resources availability. Ecosystem services and benefits for humans come later, but sometimes the perceptions of society do not match with the real recovery. These mismatches require communication and ocean literacy actions, and the benefits from the recovery of ecosystem services after restoration can cover all or a great part of the investments in the management measures. Thank you very much, and this presentation will be available in my ResearchGate profile and in YouTube.